Welcome back, AP Psych. Hope you're doing well. This is our second video on Unit 3, Biological Psychology or Biological Basis of Psychology. We just touched on part of the nervous system and the neuron and the structure and how it works and communicates and neurotransmitters. And that was a very specialized part of the brain. And now we're going to move on to the larger systems of the nervous and endocrine systems in the body and how those impact our behavior and mental processes. So you should have your set of notes out. There are some good diagrams on here you'll be filling out as you go, which should help you organize things and understand as we go through. So we're going to start with the nervous system. This consists of all the nerve cells in your body, right? Everywhere, all the neurons, all the nerve cells. And it's the body's speedy electrochemical communication system. Okay, so when we talked about neurons, we talked about how they're both electrical signals to send messages and chemical as well, because neurons don't actually touch. They send neurotransmitters across the synapse, and that's the chemical part. So the electrical part sends the message, and the chemical neurotransmitters are the ones that carry it to the next neuron so it can continue. When we talk about the entire nervous system, there's two main parts. You have the central nervous system, which is right here, made up of only your brain and spinal cord. This is the entire central nervous system right here, if we were to take it out of your body. Okay? It contains the brain and the spinal cord in the center of the body. That's how we know it as central nervous system. On the other hand, you have the peripheral nervous system, or the PNS, and this is the sensory and motor neurons that connect the central nervous system to the rest of the body. So if you were to look at this image, all these little yellow nerve cells and nerves running along the rest of the body in your fingers, hands, toes, legs, arms, that allows messages to be brought from those areas of your body back to the central nervous system and eventually up to your brain if necessary. So these are the two major parts of the nervous system: central nervous system, brain and spinal cord, and peripheral nervous system, all of those peripheral outside nerves coming from your central nervous system. To briefly cover the central nervous system a little bit closer, it's the center of the body. It's our body's main control center. We talked about neurons in the brain and how the brain communicates and the importance of that. You can kind of think of it, like we said, as its brain's control center. And you can think of the spinal cord as the superhighway of nerves and the means of transmitting messages to and from the brain and the rest of the body. All right, so it's like that superhighway that directs everything, tells it where it needs to go, sends it to the brain if necessary. And there are times, which we'll mention later, where you don't need to send a message all the way to the brain. You can respond without that. That's pretty much all we'll need to know about the central nervous system, just the brain, the spinal cord, and their major jobs. But we're going to move on to the peripheral nervous system coming up next. And that breaks down into several different categories, which you'll see. So first, the breakdown of the peripheral nervous system. We're going to talk about something called the somatic nervous system. Somatic controls all the voluntary movements and communication to and from the sense organs in our body. Okay? You control these items. They don't just happen, right? So as you're writing notes right now, that is your somatic nervous system taking control because it's a voluntary movement. You're choosing to do it. Even things like running, walking, brushing your teeth, you don't really think about them now, but you did have to learn them at some point. That's all controlled by your somatic nervous system, right? Any voluntary movements you do. So later when you're going to the gym, playing sports, playing your instrument, whatever, your somatic nervous system is in control. On the other hand, we have something called our autonomic nervous system. Autonomic is just like it sounds. It's automatic. It controls our involuntary functions or items that happen automatically within our body. Okay, things we don't have to think about, things that we have no control over, such as our breathing, our heartbeat, and our digestion. Now, some of you might be thinking, I can control my breathing. I can hold my breath. Yeah, that's true. But eventually you're going to pass out and your body's going to start breathing again, right? Because we really can't control that. And it's a good thing that we don't have to control breathing or heartbeat, because I'm sure some of us would forget to do it and we'd be dead pretty quick. So the autonomic nervous system serves a very, very important function, and that is all of our involuntary functions is what it controls. Okay? So when you think about autonomic, you should think about automatic, but that's not something you should write on an FRQ because it's not psychology-specific language. We like the term voluntary and involuntary to describe somatic, voluntary movements, and autonomic, involuntary functions. Those are the two branches. We're going to break those down here as well. So in the autonomic nervous system, you have two branches. First is the sympathetic nervous system. This is a division of the autonomic nervous system that arouses the body, preparing it to act or react in stressful situations and expend energy. You may have heard the term fight or flight. The sympathetic nervous system is responsible for that. So when you find yourself in a stressful situation and your heart rate increases, you start to sweat, that's your sympathetic nervous system kicking in, preparing you for a stressful situation and helping you get through that stressful situation. Okay? You can think of it as like, oh, your body is feeling sympathetic, that you're stressed out, and it's helping you get through it. Okay? On the other side, there's something called the parasympathetic nervous system. This does the opposite, right? Once you're all amped up and keyed up and you survive this stressful situation, whatever it is, maybe you have 3 tests in a single day at school, you're running from a grizzly bear, any of those things could kick in your sympathetic nervous system. Well, when that stressful situation is over, you need something to help calm you down. That is the parasympathetic nervous system. Okay? It's the division of the autonomic nervous system that calms the body, conserving its energy and helping keep a constant internal state and helping your body return to something called homeostasis. You need this because if we lived our entire lives with the sympathetic nervous system turned on, our lives wouldn't last very long because stress is very, very hard on our body and it breaks it down. So we need to be able to come down from that. And a great way to remember this, parasympathetic, it's kind of like parachute. A parachute slows down your fall, right? And helps you calm down after a stressful situation. Kind of like if you were about to skydive and you're jumping out of an airplane, your adrenaline, your fight or flight mechanisms are going to be on fire. Your sympathetic nervous system is going to be going crazy. But finally, when that parachute opens, it's a moment of relief, right? And you can start to calm down and relax. Your heartbeat slows down, digestion begins again, and your body returns to its normal state. So just to go over that a little bit further and kind of show you a visual of each side, we talked about how the sympathetic nervous system arouses you. It gets you ready for a stressful situation. It puts you in that fight or flight mode. Okay? When that occurs, there's some physical things that happen. Your pupils dilate, your heartbeat accelerates, digestion stops, your body stops the flow of blood to places that it does not deem essential for survival. You don't need to digest right now. You need to put your effort into whatever's causing stress. Stimulates secretion of epinephrine and norepinephrine. You know those as adrenaline. Turns off that need to go to the restroom and helps you in every stressful situation. Okay? Now, on the other hand, what physical things happen to you once your parasympathetic nervous system kicks in and calms your body? We can call this rest and digest. So those are two good ways to remember these, the jobs of each of these two divisions of the autonomic nervous system: sympathetic, fight or flight; parasympathetic, rest and digest. When that happens, your pupils contract again, your heartbeat slows down, digestion begins again, and your bladder goes back to normal, right? Your body is returning to homeostasis, to its normal resting state, so it can behave as it should. It's no longer in a stressful situation. So those are the two divisions of your autonomic nervous system: sympathetic and parasympathetic. Now let's talk types of neurons here. We didn't get into that when we talked about neurons. We just talked about their communication and how the action potential works and the types of neurotransmitters. But there are 3 different types of neurons. Okay? The first is your sensory neuron, or afferent. This carries incoming information from the sense receptors to the central nervous system. Okay? So when you think sense receptors, you should be thinking your senses, right? Your skin, touch, taste, hearing, sight, smell, right? These sensory neurons bring that sensory information in to your central nervous system to eventually be carried to your brain. Good way to remember this. These afferent neurons, afferent kind of sounds like affect. An affect is like someone's emotional state. If someone has a flat affect, they have very little emotion, right? So if you think of the term affect and emotion, your emotions are very much connected to your senses, right? So that's a good way to make a connection here. Your sensory neurons are afferent, which sounds like affect, which deals with emotion, and your emotions can be very much connected to your senses. Okay? So these sensory neurons carry information to your central nervous system. There, that information is relayed to a different type of neuron called an interneuron. This acts as a messenger between the two neurons and exists entirely within the central nervous system. Okay? These interneurons are only within the central nervous system. Right? They're the only neurons in your brain and spinal cord. Okay? They are the messenger neuron. So the information comes in from sensory neurons to the interneurons. Then they must pass that information off to what we call the motor neurons, or efferent. Okay? So you could hear either of these terms to describe sensory and motor. You could hear sensory as afferent. You could hear motor as efferent. This carries outgoing information away from the central nervous system to your muscles and to your glands. Okay? Now, easy way to remember motor neurons as efferent. Efferent sounds like effort. You have to give, once these motor neurons have gotten that information, you can then do things. You can give effort. You can move, right? Another way to remember it, efferent starts with an E. So does engine. Engine and motors go together, right? They both help make things move. Okay, and that's what motor neurons do. So information comes in from your sensory. It is passed on to the interneurons in your central nervous system. They then send the message out and how to react to your motor neurons, and your body's able to do that. Here's a visual for you, for those visual learners out there. This is how the three types of neurons communicate. So like we just said, if we're zooming in on your hand here, okay, you have dendrites in the skin, right? That's going to take in the information from your environment. So those dendrites take in the information, and your neurons are firing and sending that information. And the sensory neurons are the ones communicating down your arm, right? Until it gets to the spinal cord. And here you can see a sensory neuron is communicating across the synapse with an interneuron. That interneuron only exists in the central nervous system. It then passes that information along to your motor neuron. Once the motor neuron gets that information, it can then tell your muscle fibers to contract or relax or do whatever you need to in the situation to react or do what you would like to do. Okay? Now, I mentioned earlier how sometimes information doesn't have to go all the way to your brain. In a situation where a reflex is necessary, let's say you put your hand on a hot stove, you remove that hand without even thinking about it, right? It's an involuntary reflex. You don't even make the decision because your body skips your brain. It goes straight from your sensory neuron to your interneuron, but doesn't go up to your brain. It says, nope, we got to make a fast decision. Boom, straight back to the motor neuron. Okay? So that would be an instance where the information doesn't make it to the brain where it normally does before it comes back to your motor neurons in a reflex situation. So that might be something to note and to write down. Reflexes do not have to, the information does not have to travel to your brain, only to your spinal cord. All right, so that wraps up our nervous system talk and the branches of it. Next up, we have the endocrine system. Okay. The endocrine system kind of works in conjunction in many ways with the nervous system. But while the nervous system is a very fast, quick-acting system, the endocrine system is the body's slow chemical communication system, right? We know the nervous system is electrochemical. The endocrine system is solely a chemical experience. Okay? Under normal circumstances, it works in parallel with the parasympathetic nervous system to sustain our basic processes, right? So it helps our body stay in resting state and in homeostasis. However, in a crisis, it will support the actions of the sympathetic nervous system, which we'll see. Okay, so some of these endocrine systems or glands that we're going to discuss: pituitary gland, thyroid, adrenal glands, pancreas, and then your gonads, which are your ovaries or testes. Okay, so we'll get into each one of those as we go. Here's an example of how your endocrine system could work. Okay. Let's say you're walking down the street and a man pulls a gun on you, right? Your sympathetic nervous system is going to kick in, right? You're going to enter fight or flight mode, like boom, okay? Now, in conjunction with your sympathetic nervous system, your endocrine system is going to release the hormone epinephrine or adrenaline into the bloodstream. This sustains the body's defensive reaction or fight or flight response. So when that guy pulls the gun, your fight or flight response kicks in, adrenaline's being released into your bloodstream, and it gives you that long-lasting energy that you need to potentially run away or get out of the situation. So the endocrine system is finishing what your sympathetic nervous system started. It's keeping your heart pounding, keeping your muscles tense. You're ready for action until you're finally out of the situation. Okay, you hear crazy stories about things that people can do and massive feats of strength or endurance that they perform, and that's because of the hormones in their blood, adrenaline, pushing them through it, right? And then after that, they kind of crash and they're super tired because they've done something almost superhuman. That starts with your sympathetic nervous system, and it is continued and prolonged by your endocrine system releasing those hormones into your bloodstream. So our first gland we want to touch on is called the pituitary gland. And we'll get into this a little bit more again when we get into our brain structures, but it's this tiny little bulb-looking structure in your brain. And it is known as the master gland. Right? It attempts to keep all of our endocrine responses under tight control. So it is the thing that tells us or tells your other glands when to release adrenaline. While it is the master gland, it is under the control of the hypothalamus. And the hypothalamus is a brain structure, so it is part of the nervous system, right? So here's another connection between the nervous system and the endocrine system. So as the hypothalamus communicates, it allows the pituitary gland to send out signals to release hormones from the other glands in your body. So this is the master gland. Up next, we have the thyroid and parathyroid glands. You can kind of think of it right here in your throat area, if you're Adam's apple for our males out there. It regulates your metabolism, your physical growth and development, and calcium rate. So it helps with regulating the amount of energy you burn through your metabolism, how you grow and develop as a young person, and calcium rate as you get older. As women enter menopause, it can impact their calcium rate, and they can have issues with their thyroid glands as well. So this is something that helps develop our body and keep it in a constant state of the right amount of energy through our metabolism. Next up, we have adrenal and pancreas. Right? Our adrenal glands, I'm sure you can guess, they regulate fight or flight response and a little bit of our metabolism. And they release epinephrine or epinephrine, which is just a fancy term for adrenaline. And our pancreas regulates the level of sugar or glucose in the bloodstream. Right, that's the pancreas here. And your adrenal glands sit right atop your kidneys. Your pancreas and the glucose levels in your blood, this is something that diabetics have issues with. So if your pancreas is malfunctioning, it may lead to diabetes or things like that. So it's very important, and it helps regulate our blood sugar. Finally, we have the gonads. These regulate bodily development, our secondary sex characteristics, and they maintain reproductive organs in adults. They produce sperm and eggs. Okay, so by regulating bodily development, our secondary sex characteristics, you can think of those as, broadening of the shoulders in males, development of breasts in females, things like that. And the hormones that they release Testes produce testosterone in males to do those things. And in females, they produce estrogen and progesterone to help develop in that way. So, very last thing, hormones in general. Those are the things we just touched on that these glands of the endocrine system release. Okay? They're chemicals synthesized by the various endocrine glands and secreted in the bloodstream. They have similar structure and function as many neurotransmitters, but there are key differences. Okay? So there's some big differences between hormones and neurotransmitters. Number one being speed of transmission. Okay? Hormones are slow. Could be minutes, could be years, could be days, right? When you think of things like puberty, right, that takes years. Minutes for adrenaline to take effect. Days when females go through periods, things like that. Those are all hormones at work. Neurotransmitters, fast, right? We talked about those neurons communicating in like 100th of a second each time messages are sent. Those happen fast, and they're not very long lasting, right? And that gets us to our next thing, length of influence. Hormones last much longer. Could be days, weeks, like we said, could be years, right? These hormones stick around in the bloodstream a heck of a lot longer. Neurotransmitters, it's over in less than a second, right? Very brief duration. They do their job, get in, get out. So, method of transmission, hormones flow through the bloodstream, and neurotransmitters are obviously carried by and passed along neurons. Okay? So they do work in conjunction with each other in helping the body communicate and develop and handle stressful situations and returning the body back to rest. But hormones are much longer lasting and more influential in terms of our lifespan. And neurotransmitters, much faster, help us do our day-to-day, task-to-task things as we go about our life. So that should wrap up our notes for nervous and endocrine system. Just a quick, brief overview for you of each of those systems. We'll be doing some work in class to help you differentiate them as well and help make them stick. If you have any questions, as always, let me know. Send me an email. See me at school. And I hope you enjoyed. Thanks.